back, class. We're in Chapter 6, Business Intelligence and Analytics. It's pretty interesting. What I'm going to do, I'm going to cover a couple things differently than what's in the chapter. I think the chapter PowerPoint does a very good job of explaining business BI, business and intelligence and analytics. But I just want to look at a couple of tools that's used in the analytics process. Splunk and Hadoop and how we integrate those together. So when we think about Splunk, what is that? It's a big data platform that collects and analyzes machine-generated data, and it does it in real time, and it really helps to derive that operational intelligence. Where I work, like I said, I'm a senior cybersecurity analyst, and we use Splunk immensely in the cybersecurity arena, especially with looking for trends, looking for different types of analytical things that may be going on in our log files. We pull log files from many places, from every computer that's generating a log. We bring in all that log data. So if you can think about 1,300 computers, plus all the servers and all the network equipment, routers and switches, we bring all that log data together, and then we're able to bring it into some type of context using Splunk. If you ever wonder where the name Splunk came from, well, from spelunking, the guys who go down into caves. So that's where they kind of get that name from, meaning that they're able to go down and dig through data, kind of like in a cave or a mine, like data mining. Okay, anyway, so when we talk about data, machine data, what does that look like? What does that look like? Okay, let's take a look at this example that we have up here, okay? Now this is a tweet, this is hypothetical, but someone bought a product and they sent back their comments via Twitter. Well, that's what that data looks like from a machine perspective. That tweet was pulled in. Now coming up the stack, this is where the help desk was called, and you see that you have all other tracking data in here, the time, the date, it was assigned an event number, and everything that's going on with it. Now in the middleware, between the order processing and the source, we have middleware that does the processing. And you see here we have more data in here that talks about things like web logic and the database system drivers that was going on within the database itself. And this was the actual source of the order. So you see there's a lot of stuff in here, and just looking at it as a human, the problem we have as humans, that we have a problem many times looking at all this data. And trust me, this is one small snapshot of data, and correlating that and trying to make some type of sense, some type of logic out of that data. So when we start really looking deeper into this data set, you see there's a lot of rich information in here. Everything like, for instance, customer IDs and the order ID, all this different information, time waiting on hold, customer ID, the company Twitter ID, the customer's tweet. All this is critical information that's in these disparate data sources. Because in the past, all these data sources are on separate databases, and they're being generated, individually. So as a human, you'd have a hard time looking across all these databases to pull it together. But that's what Splunk. So Splunk is able to really unlock critical insights, and it's able to now start doing some linkages, between the customer ID that was in the order to the customer ID that's in the data processing path to the firmware, and link that to the Twitter ID. Now you can bring all these pieces together and start making some type of correlation from multiple data sources and databases, and now you're able to tell a story. Like I said, we do this. We do that very similarly in the cybersecurity world, where we're pulling in log data and we're pulling in information from several different databases and data sources. And now we're trying to be able to correlate that to be able to tell a story. For instance, if someone has come into our network and as a malicious actor, now we're able to track and see where that individual went to the network, because many times the trail may traverse several different data sources. So Splunk is able to pull all these data sources together, and then we can do a Splunk query using the Splunk query language, and actually piece all these different pieces together. So that's kind of the power behind Splunk. And the great thing about Splunk is that it scales very well. Now, if we look over here, these are the three basic components of of Splunk. You have a Splunk forwarder, indexer, and we call it search head. The forwarder, this is a little piece of software, a code that's actually loaded on all the different machines or devices that you want to pull information from. For instance, where we use it at, we have a Splunk forwarder loaded on every computer. So when we build a new computer, before we take it to the end user, we install the Splunk forwarder. Now the forwarder, all it does is that it reaches out and grabs that log data and it pushes it up to a server, and we have a server, a Splunk server, that gets all of this data. Right now it's just data. Now on that Splunk server, we have an indexer running. And what the indexer does, it just makes it indexes of all this data, and then it puts it into a logical fashion. For instance, so that way it starts indexing in things maybe by time of day. And so it starts looking for fields across all this data that matches. It may be by an event code. For instance, if data from this database has an event code that matches data from another database. And Splunk is smart enough to know that because they built that in, that it knows how to recognize data sources. For instance, in the cyber world, they've already built in what to look for in different types of log files that your computers and servers generate. Now that we got an index, I mean, it's put into these categories, it's all categorized. Now we have a search head, and what the search head does, it's able to search through this indexer based on what we want to look for. So the search head is really what the human interfaces with, is that now I can write a different types of scripts or different type of search patterns to go and look through these indexers that's now able to start pulling up lots and lots of rich data that now is able to become information and wisdom and knowledge and on up to wisdom. So that's, and the way Splunk is built is able to scale to where it is able to index hundreds of terabytes. Now we're talking petabytes of information. That's a lot of data. But Splunk does it pretty well. Now, the other tool we're going to talk about is Hadoop. If you go back on the history of Hadoop, it was really originally funded back in the 90s, I think, or early 2000s, maybe around 2006, 2005. By Yahoo, and they were looking for a way to do kind of like parallel processing. So, and they sold the project to Apache, the Apache Foundation, which is a Linux variant that really most of your servers that on the internet today is, runs Apache for web services, as for web servers and Samba types of applications. So what is Hadoop? Hadoop is a project developed, like I said, open source software, and it's really for scalable distributed computing. And when you think about distributed computing, what that's talking about really is now I can have multiple computers over a large geographical area or a logical map that's able to work on one or multiple problems at the same time. So now I have the power of multiple machines that are able to do searches, to do sorts, to do different things with data. And so that gives you a lot of capability. So now I don't have to really buy one huge, Cray computer or, what was it, Isaac, I think, the one that IBM built. So I don't have to have this giant supercomputer. And now I can use small, low-cost machines that I can parallel process and do distributed computing. Like I say, the software library is a framework that allows for the distributed processing of large data sets across clusters of computers using single programming modules. And it's really designed to be scalable. So you can scale up from single individual servers up to thousands of machines, and to be able to do computation storage. Now, so what was Hadoop designed? It was designed to do a pretty simple thing: how to process big data with reasonable cost and time. Because, like I say, because everyone can't afford a Cray computer, a supercomputer. So this applied a way to do that across multiple computers that you can share out. Now let's take a look at an example about how large data set computing example. All right, see the New York Times newspaper, right? They had a thing where they were trying to generate PDFs of articles that was written between 1815 and 1922. That's a lot of years there, right? About 70 years, 70, 71 years, something like that. So if you can think about the number of articles, and because newspapers were really big then, that were written, so that they were now trying to put on PDF. So they wanted to pre-generate and statically serve articles to improve performance. So they used Hadoop and a database system called Mapreduce, which actually works really well as well, running on a Amazon EC2 SC. If you're familiar with Amazon, we talked about that in the cloud. Remember cloud, Amazon AWS, Amazon Web Services. Their EC2 server and the S3 storage. And they were able to convert about 4 terabytes of TIFF files or photos, old photos, into 11 million, yes, million PDF articles in 24 hours. Yeah. So that gives you an idea now of how using Hadoop you're able to take large data sets, large amounts of raw data, and do processing. Pretty neat, isn't it? Now, when we think about Hadoop, Hadoop comes in modules. There's different modules. And these are some of the basic modules, and there's other modules associated with this. And I always recommend go out to the Hadoop website, and you get more information you ever want to know. But like I say, the common module, that's basically the base model of Hadoop. Like I say, it has all the common utilities that support all the other modules. Now, when you're thinking about when you're operating across multiple computing platforms, you have to have a file system that's capable of managing all these file transactions. So what Hadoop has its own file system. Hadoop Distributed File System, HDFS, and that's trademarked. Actually, that's a distributed file system that really provides the throughput, the high data rate throughput to all these different applications. Hadoop Yarn, you'll hear this term yarn, which means yet another resource negotiator. And really what that is actually it's a framework for job scheduling and cluster management. Because if you're operating in a distributed environment, you have to be able to schedule and manage all these different computing clusters that are running different times and different load balancing, those things. So that's what Yarn. And we look at Mapreduce. Like I say again, it's a Yarn-based system that's made for parallel processing, large data sets. That's what Mapreduce really is. Like I say, so when you're doing parallel processing, if you think about running a database on 10,000 machines, the same database, and you're going to schedule this portion of the database to be on these 5,000 machines, and this portion to be on 2,000 machines, and this portion to be on 3,000. So all that has to be well synced and well orchestrated. And so Yarn, Mapreduce, that's what they do. Hadoop Ozone, like I said, that's an object store. That's kind of where it maintains the object store. And it also has a machine learning engine called Submarine. Okay, so we talked about Splunk as a data analytic tool that's able to analyze and bring content. And we talked about Hadoop, right, which is parallel processing, how you do big data sets. Well, what happens when I bring these two worlds together? I get something called Hunk. Yes, now I'm serious. This is what it's called. So we take Hadoop plus Splunk gives you Hunk. I know. We should have a centerfold probably for Hunk, right? No, wrong Hunk. But what this gives you though is the best of both worlds. Really, it's the way you bring this together where you can have the distributed processing for large data sets. Then after it's processed, you're still able to use the Splunk forwarders and the indexers and the search heads now to bring context to all this data at the same time. So there's several pieces to this Hunk engine. But yeah, that's the gist of how this works. And in big organizations like Google lives and dies by Hadoop as well as Splunk for their things that they do with data analytics, especially if you think about clicks. When I mean by clicks, not people who are in one little group together. No, I'm talking about internet web clicks, that they're analyzing every move that you're making on the internet. Think about all that data of everybody that's clicking and searching on the internet, and that's how now, if you notice, if you go out to Amazon and you search through Amazon for bicycles, the next day you come to your computer, you log in, and you go to a completely different website, and over here on the side, what shows up? Bicycles. How did that happen? Because your click patterns have been analyzed, and they're using BI, business intelligence, so now they can, with Web 3.0, remember those web generations we talked about? Web 3.0, Web 4.0, so now they can start personalizing your internet, your web experience. So things that you've been searching for, we're able to start pushing that closer to the customer. It happens all the time. And tools like Splunk, Hadoop, are, when they bring those together, being used to do that. So that's what we call an integrated platform. And you think about an integrated platform where we're using Hadoop clusters down here to do the parallel processing, as well as it also uses SQL and NoSQL databases that's able to do high definition, high order processing, run that through Splunk, and now you're able to do all the analysis and exploring and visualization and set up dashboards and be able to share that out. So now you're able to make business decisions out of all this data that you have been able to process in a very, very large fashion. So with that said, I know this is a pretty short lecture this week, but what did we look at? We looked at some of the analytical tools, like Splunk, Hadoop, and there are others. There are, you got MongoDB, Accumulo. I mean, the list goes on. There's many pieces to this, but these are just two of the kind of the ones that I'm familiar with, that I've used in the past, especially Splunk. We get a lot of mileage out of that. So I hope this helped you out. Maybe you take this, combine it with the course PowerPoints, and give you kind of a snapshot or a look behind the curtain of some of the tool sets. Hey, thank you very much. Hope this helped you out. If you have any questions, please feel free to contact me. God bless.